Welcome! In this video, we are going to answer a business operations question about assembling cameras and drones. We will carefully walk through how workstations, project assembly teams, and robotics affect production capacity. We will then identify which statements about assembly operations are true. We will go slowly, use a visual diagram, and then finish with a short recap. Let's start with a visual model. Imagine a factory floor. We have a set of workstations lined up. Each workstation can be operated by a project assembly team, or PAT for short. If a workstation is empty, it cannot produce anything. So the maximum output depends on two things: how many workstations we have and how many teams are available to staff them. Now, let's define the key ideas. First, workstation capacity. This is simply how many stations exist, multiplied by how much each team can produce. Second, labor productivity. Each team can build a certain number of units per year, and this depends on training, wages, and technology. Third, robotics upgrades. Robotics usually reduce the number of human teams needed for a given output, which lowers labor costs, but the machines are expensive, so depreciation costs go up. Let's put this into a simple formula. The maximum production capacity is the number of workstations multiplied by the annual output of each PAT. This is a core truth in assembly operations, and it is one of the most common correct statements you will see in questions like this. Now, let's use an actual numerical example. Suppose we have 100 workstations. Each project assembly team can build 3,000 cameras per year. Then total capacity equals 100 times 3,000, which gives 300,000 units. Now imagine we add a robotics upgrade. Suppose productivity rises by 20%. Each PAT can now build 3,000 times 1.2, which is 3,600 units. The new total capacity becomes 100 times 3,600, which is 360,000 units. This shows why robotics can increase output even if the number of workstations stays the same. Now, let's summarize the true statements. Statement A is that increasing the number of workstations directly increases the maximum annual production capacity as long as there are enough teams to staff them. That is true. Statement B is that investing in robotics reduces labor costs per unit, but increases depreciation costs. That is also true. Statement C is that the maximum capacity of the plant equals the number of workstations multiplied by the annual output of the project assembly teams. That is the same formula we used, so it is true as well. Let's wrap up with a short recap. The key idea is that output capacity is driven by two simple components: how many workstations you have and how productive each assembly team is. Robotics can make each team more productive, which increases capacity, but it also changes your costs by reducing labor expenses and increasing depreciation. So, the true statements are exactly the ones that connect capacity to workstations, connect productivity to teams, and explain the cost trade-off of robotics. If you remember these three ideas, you will be able to answer almost any assembly operations question correctly.